Hey, this is Mr. Aiden. This is AP Calculus AB. We are in Unit 4, which is Contextual Applications of Differentiation, and that's a lot of words to say. We're going to take our derivatives, our differentiation, and we're going to put them in context. We're going to put them into a real-world scenario, and that is going to help a lot of my students out who have had me for physics before, or chemistry. A lot of physics and chemistry students that have had me this ends up being the very easy parts of calculus. The students that have not had any context behind their mathematics, just theoretical, this ends up being their hardest part. And so I'm going to try to bring you through it. In this first video, we're going to be doing contextual meanings of derivatives. We're going to take a look at what derivatives are in context. So let's take a look. Let's say Mr. Dale drove from all the way from Ocala, and he is driving to Tampa to get Mrs. Dale some special kind of coffee she's craving for. She's pregnant. She needs coffee. No one's going to talk to her. The function d gives the total distance Mr. Dale has driven in miles and t hours after he left. And so what's the best interpretation of the following statement? The following statement says d prime of 2 is equal to 100. And so what does this mean? What is this trying to display? And of course, think about, let's say we're talking about d of 2 is equal to something like 400. What does that mean? Well, that means distance as a function of time is equal to 400. Okay, so the time would be 2 hours because our time is in hours after he left. So 2 hours after he left, this distance, he will have driven 400 miles. And so that is what d of 2 equals 400 means. But what does d prime of 2 mean? Well, remember, what does the derivative mean? The derivative means the change of that distance over the change in time. Another way to write d prime of t would be the change of your distance over the change in your time, which you would call the velocity function. Okay, the velocity function. So, or speed in some way. And so the change of the distance over the change in time at 2 hours is equal to 100. And what are the units of the change of distance over the change of time, or velocity, would be miles per hour. So at exactly 2 hours after he started, he's driving 100 miles per hour because his wife is pregnant. When she's pregnant, you got to get her coffee. So he's driving 100 miles an hour on the interstate going to get her coffee because he is going to get beat if he doesn't bring it back. Okay, here's another example. A pool is drained of water, and it says let V give the volume of the liquid in liters. So V, the volume of T, is in units of liters. T is in units of minutes. Okay, and so what is the best interpretation of this statement? The slope of the tangent. And what is the slope of the tangent? The slope of the tangent is the derivative, isn't it? The derivative. So the slope of the tangent, or the derivative of the volume with respect to time at time equals 7 is equal to negative 3. So the change of your volume at 7 minutes, because time is in minutes, 7 minutes is equal to negative 3. So what is that saying is this, is, V prime of t is the change of your volume with respect to time. Okay, so at the time is equal to 7 minutes, the volume is negative 3. Actually, not the volume is negative 3, the change of the volume with respect to time, how fast this volume is coming out, is negative 3. Now, what does that negative mean in context? It means it's draining. It's getting less. It's getting less and less and less and less. And so what would be the units of this negative 3? The negative 3 would be liters per minute. It's the rate at which the pool is negatively decreasing. It's draining out. So if you were putting water in the pool at some rate, okay, in liters per minute, the units really help you out in these context type problems. And that is the contextual meaning of derivatives. Make sure you really take a look at your units. Your units tell you everything. When you're talking about something like time would be in seconds. So time would be in seconds or minutes or something like that. Let's say we're talking about area. Area would be in meters squared. And so if we're taking a look at the rate of the area with respect to time, that would be meters squared per second. And that would be the change of the area with respect to time right there. That would be the derivative of the area with respect to time. And so anytime you're doing these contextual meaning of derivatives, really pay attention to the units. The units help you out big time. Okay? Thanks, guys.